Okay, let's graph this function. F of x is 3 cosine of 3 halves x plus 1. Okay, let's analyze it. The midline as an equation is y equals 1. Okay, comes from here. The amplitude comes from here. It's just 3. It's a positive number, always a positive number. Is it reflected? No, because there's no negative sign here. What's the standard period of cosine? It's always 2 pi for cosine. Okay, so what's the frequency? The frequency is the coefficient on the x, often called the b. It's what's multiplying to the x. So that's the frequency. It's 3 over 2. Now, is this faster than normal or slower than normal? 3 halves is 1.5. If it's greater than 1, it's faster. It's speeding up. Okay? So which means this function is going to be shorter. When the frequency is quite fast, you're going to have shorter periods. Okay? The standard thing that you do to figure out the period of the graph the function that you're graphing is you divide. This has what's called an inverse relationship with the period. The faster the period, the bigger this is, the smaller this is. But divide. 2 halves, and I'm going to divide by 3 halves. Oop. So when you divide with fractions, you keep, change to multiply, and flip to the reciprocal. So what do we have here? When we multiply, we're getting 4 pi over 3. Is 4 pi over 3 shorter than 2 pi? You bet it is. Because what is this? That's 1 1/3 pi. It is shorter. So that's going to be the length of one period of this function. All right. So this is going to be our parent table, and this is going to be our transform table. Parent is x and y, but y, which is the same as f of x, is your basic cosine trig function. And here are the x's that we're going to use. These are standard. This is standard. And the cosine values for these x's, these angles, is 1, 0, -1, 0, 1. If you doubt that, just go once around the unit circle from 0 back to 2 pi, and then ask yourself, what's cosine of this, 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 and this? These are the 5 values that I just explained, or that I just wrote down. Okay. Now this is a really crucial step here. This part here is going to express the transformation of the inside of this function. And if you remember, when you do transformations of parent functions, when you're looking at the inside and what it does to the x, what you have to do is the inverse of what is being done here. So I'll give you an example. Simple inverse would be if it had said x minus 1 inside the function. Okay? The transformation would be x plus 1, because you do the opposite of this. Well, in this case, we're going to do the opposite of 3 halves. We're going to do the inverse of 3 halves. What is that? That's the reciprocal. It's 2/3. Okay? This is what you would call a stretch, but when it's on the inside, it's a compress. That's another way to think about it. Okay? Because we're doing the opposite. So therefore, to express that transformation, it's 2/3 x. For the y, this is usually easier to kind of read from the function. It's that part of the function that is outside the heart of the function, which is the cosine part. And so, which is considered the y, 3y plus 1. Okay, so these are the instructions for what to do with each of these 5x's and each of these 5y's. Okay, I have a little reminder here about common denominator, which means now, you're going to have to multiply 2/3 times each of these fractions. What a pain. But it's going to be less painful if we're using a common denominator. The denominator over here, well, it looks like we have 2's. The denominator over here in the transform table is 3. We're going to have to use 2/3 to 3 as a denominator quite often. So a common denominator between the two of them would be 6. I would like to use to write all 5 of these transformed x's using sixths. And you'll see. But let's just do this. 0 is my x, so 2/3 of 0. Okay, that's an easy one. That's 0. What's 2/3 of pi over 2? Okay, when you multiply fractions, you just multiply the tops and the bottom, so you're going to get 2 pi over 6. Okay, that's our common denominator, which is good. How about 2/3 times pi? Well, that's 2 pi over 3. But let's express this in terms of the common denominator. Okay, let's make it 4 pi over 6. You'll see why we're doing that. Let's just multiply that by 2, multiply that 2. Keep the common denominator. Next, we're multiplying 2/3 times 3 pi over 2. Okay, this is nice because 2 times 3 pi is 6 pi. 3 times 2 is 6. We have that common denominator. I'm just advising you to keep it, 6, 6, 6. And then finally 2/3 times 2 pi. Okay, this will turn out to be 4 pi over 3. But let's use that common denominator and just double each side. So that's 8 pi over 3. Okay, 8 pi over 6. Okay, everything that we've just done here is in sixths, except for this one. Let's call that 0 pi over 6. The reason this is good to do is because now you can look at the numerators and then see if it fits a pattern. Look, 0, 2, 4, 6, 8. Each step is 2. Each step is 2. 0 to 2 to 4, 6, 8. It's very easy to make a mistake somewhere over here. But you'll know if you made a mistake if somehow you don't have a nice kind of step pattern, 0, 2, 4, 6, 8, which all works because you have the same denominator. You can measure the distance between each of them and exactly using the same units or denominator. Okay, so these are going to be my 5x points. Now, this side is usually much easier to do. So I'm going to take the 1. 3 times 1 plus 1 is 4. Take that 0. 3 times 0 plus 1 equals 1, because this is 0. Take that negative 1. 3 times negative 1 plus 1, negative 3 plus 1 is negative 2. Back to, okay, so this and this are going to be the same, so that's going to be 1. This and this are going to be the same, that's that going to be 4. Okay, this should also have a pattern that you can recognize. With cosine, it starts high, crosses the midline, hits the low, crosses the midline again, and then hits the high. High, mid, low, mid, high. Okay, so we have our 5 values, we have our 5 x values, and now the easiest part is to plot it. Once you have your transform table. Okay, so here I'm going to plot 2, 3, 4, 5 x points, and they were 0, 2 pi over 6, 4 pi over 6, 6 pi over 6, and 8 pi over 6. Okay? And then our y values were 4, 1, and then negative 2 is down here. Okay? Those are there are only 3. So the first point was 0, comma, oh, I'm sorry, 0, comma 4. Our second point was 2 pi over 6, comma 1. So right here. Our third was 4 pi over 6, comma negative 2. So 4 pi over 6, negative 2. And then our fourth point was 6 pi over 6, right here, comma 1, back up to the mid. And 8 pi over 6 goes with the 4. So here, this has the shape that we expect from a cosine graph.